This video is going to walk you through everything that you might have missed today in 8th grade honors math. The first thing we did was a do now, where we practiced solving equations by doing the same thing to both sides. I want you to do 1 and 2. I'm not going to go over 1 and 2 because they're very similar to the do now from Monday. So if you need help on those questions, I suggest going back to the do now video from Monday to watching me do those. And then I'll go over question 3. So pause this video and complete the do now. We'll talk about question 3, and you can go back to Monday's video to go over 1 and 2. Okay, so you should have completed the do now at this point. Let's talk through question 3. We know that our goal of solving each equation is to get x by itself. And to get x by itself, we'll first need to get x over 7 by itself. So I want to get rid of the minus 4. And by get rid of, I mean conduct the inverse operation. And so I'm going to go ahead and add 4 to both sides. Notice how I write plus 4 on both sides, and I'm going to draw a line underneath that first step so I can separate my work. Now we'll rewrite our equation. On the left side, the plus 4 canceled out, so I have x over 7. And on the right side, I have 53 plus 4, which is equal to 57. And so to solve this equation, I now need to get x by itself. I know that the inverse operation of divided by 7 would be multiplied by 7. So I can multiply both sides of this equation times 7. And so I have 57 times 7. I'm going to draw that line underneath so I can keep track of my steps, which is 399. And of course, divided by 7 and times 7 cancels out. So I end up with x all by itself. Okay, let's take a look at today's lesson. Our learning target for today, which you can see in the main folder of Wednesday, is I can apply a dilation to a polygon using a ruler. We stopped about halfway through lesson 3 in the video from Monday, and we're going to pick up where we left off at 3.3. One says, using a colored pencil, draw the images of points P and Q using C as the center of dilation and a scale factor of 4. Label the new points P prime and Q prime. I'm going to show you how to do P prime, and I'll have you do Q prime on your own. Remember that when we're dilating a point from a center, and in this case the center is C, that means we're essentially extending the location of a point along a line segment that moves through the point we're dilating. So in this case, I know that I'm going to end up dilating point P along the black line, because the black line is a vector that moves from C through P and continues on. Now, I know that my scale factor is 4. And of course, we don't have a ruler when we're working on Classkick, but we can get creative with our line tools. I'll make this line red and increase the size so you can see it clearly. If this is the distance from C to P, I know that my scale factor is 4, which means that the distance from C to P prime is going to be 4 times as long as the distance from C to P. So I can take my line segment, I have 1 distance, 2 distance, I can even spin it to get 3 distances, or you could use the pen tool just to mark where you stopped and then measure your 4th distance. Your measurement might not be perfect, but we know that point P is going to lie, or I should say P prime is going to lie just about here, 4 times as far from C as the original P. And we end up with P prime. Now, go ahead and pause the video and try to do the same thing for Q prime. Okay, so you should have dilated Q prime. It looks almost the same as P prime, except now we're working with a line that goes from C through Q, and you'll end up with a point that is about or it should be exactly, but since we're on the computer, Q prime will be about 1, 2, 3, 4 times as far away from C as your original Q. Now, the next set of questions asks you to dilate with a scale factor of 1/2 instead of 4. And so if we look at P prime, I'll demonstrate P for you again. We know that if we were dilating by 1/2, P double prime, that's this notation right here, P with 2 apostrophes, is going to end up halfway between C and P because P double prime is half as far away from C as P. P double prime. And you can go ahead and pause this video and repeat that process for Q double prime. So you should have ended up with a point Q double prime that's right about here, halfway between C and Q. And this would be Q double prime. And so notice that whenever we dilate along between points, it always needs to fall along this vector or line segment from the center to the original. So in P, it fell along the line segment from C to P, and in Q, it fell along the line segment from C to Q. Let's go ahead and turn the page. If you need to pause the video to get caught up on notes, you can do so now. We're going to skip question 3 for virtual because it's going to be a little bit too tricky to draw on the Classkick. Know that if you were good on questions 1, these dilations here, you understand exactly what dilations mean and how to dilate individual points. So it's nothing to worry too much about. The summary of this lesson and what's most important to know is that when we have a center of dilation A, we can find dilations of the point B by moving along the line segment from A to B that also extends beyond B. So the vector that goes through A and B. And we know that we're measuring the distance between the new points. So the distance between A and C is twice as much as the distance between A and B. And the distance between D and B would be 1/3 as much as the distance between A and B. So don't close Classkick, but at this point you're ready for the cool down from lesson 3. So go ahead and head to the Wednesday folder and complete this exit ticket. Come back to this video when you're finished and we'll start lesson 4. Okay, so lesson 4 is dilations on a square grid. And in this lesson, we're going to be focused on completing more dilations with some grid points. Let's start with 4.1, estimating a scale factor. Pause this video and complete 4.1. So you should have answered 4.1. Point C is the dilation of point B with a center of dilation A. And it's asking us to estimate the scale factor. Well, we know that the scale factor is how many times further away point C is from A as compared to point B. I can use that same line segment trick where I draw a line segment from A to B. I know this is the distance from A to B. I'll change the color to red. And I can see that the distance from B to C is more than another line segment, meaning it's more than twice as much. Because if I have 2 line segments, 1, 2, I just copy and pasted my red line, I have a little bit of leftover space to get me to C. And so I'm going to estimate that the scale factor is about 2.3 because I know that it is more than 2, but it looks like it's less than 2.5 because if I did another red vector, I just copied another one, point C is less than half of that third red vector. And so the distance from A to C is about 2.3, 2.2 as far as the distance from A to B. All right, our last major activity today is going to be 4.2, and I want to help you get started on question 1, and then I'll send you off to finish on your own. It says, find the dilation of quadrilateral ABCD with a center of P and a scale factor of 2. When we're dilating individual points, it's much easier than trying to dilate the entire quadrilateral or rectangle all at once. So you want to think about dilating A with a center of P. And there are 2 ways that we could do that. The first is we could just imagine our line segment. We know that the distance from A to P is this red line segment, and the distance from P to A prime will have to be twice as much. And so I know that A prime is going to end up right about here because it's twice as far from P along the line segment of AP. And when I say line segment, I should say vector because the line segment continues. Now, the other way that I could solve this problem, and I'll zoom in, is I notice that P is one space horizontally from A. I'll color code that in blue. And I know that A is 2 spaces vertically from P. So it's 1 up and 2 over. And so if my scale factor is 2, I know that my horizontal distance is going to double. It's going to be multiplied by 2. I'm going to go 2 over instead of 1 over. And my vertical distance will also be multiplied by 2. I'm going to go 4 up instead of 2 up, and I end up at A prime. Either way, you end up in the same place. And so when you're answering question 1, and I want you to finish questions 2 and 3 as well, you're dilating these shapes. Focus on dilating the vertices or the corners of the shapes before you try to draw the shape, and then you'll be able to connect those points. So go ahead and try these questions. If you need help or have questions, make sure to send me an email and let me know if you need anything.